Okay, we're gonna whip through this really quick right here. I'm also gonna make reference to my sheet here that I have things on there, so suggestions that you might want to modify and whatnot. Okay, so let's just jump right in. So to begin, we're starting with find the side lengths for size P and Q. Well, that 30 right there, this little block right there, means that I'm dealing with a 30, 60, 90 triangle. So we go back to our sheet. There are 30, 60, 90 triangles and 45, 45, 90 triangles. Now, the big to do with those, the big deal is that there's like a certain setup that's with those special triangles that allows you to, if you know one of the sides, you can figure out the lengths of the other two sides. There's a pattern or a setup. And so the 30, 60, 90 is kind of all sort of focuses on the side that's opposite the 30-degree angle. So I'm just going to give it a name. I'm going to call the side that's opposite the 30-degree angle, I'm going to call it R. And so then the hypotenuse is 2 times that, which is 2R. And then the remaining side is R times the square root of 3. Okay? So I'm going to take that and I'm going to go back to this and let's draw it right here so we can see it really quick. So we got 30 right here. Now, because this is 30, this is 60, it would be either way. It'd be fine either way. So I've got 2R here, I've got R here, and I got R times the square root of 3. So let's just think about what we got here. So if I've got 5 here, that means R is 5. So then that means P, which is going to be 2R, is going to be 2 times 5. So P equals 10. And then Q is going to be R times the square root of 3. So Q is 5 square root of 3. And those are my two answers for that. I mean, now you could have a 45, 45, 90 triangle, and that works similarly. The smaller sides, or the legs as they're called, right? They they are, I gave them a label, I called them C. So there's C, and with C, um, the hypotenuse is length is C times the square root of 2. So if I know one of these two sides, I know the other one is the same, and then the hypotenuse is C times the square root of 2. All right, so now let's jump into the next one. So with this next one, we're looking at SOHCAHTOA, right? And if you write it up here, so sine is the opposite side length divided by the hypotenuse. Cosine is the adjacent side length divided by the hypotenuse. And then tangent is the opposite side divided by the adjacent side. So how does that relate to what I got? Well, we find a value of reference or a point of reference. In this case, we're looking for sine of A. So that means this is my point of reference. So sine says opposite. So the opposite side divided by the hypotenuse. So I'm just abbreviating. Opposite. So the opposite side in this case is 8. And then the hypotenuse is the longest side, that's 17. Bada boom, bada bing. Whoa, let's write that again. Let's write it like this. So then let's say, what about cosine of A? So we still got the same point of reference, right? But this time, we're going to the adjacent side of A. So the adjacent side is the side next to, right? Next to. So that's going to be 15. And then the hypotenuse is still 17. Well, what about the tangent of A? Well, the tangent of A is opposite over adjacent. So opposite over adjacent. That means that we go opposite over adjacent. So that's 8 over 15. Well, let's think about what about sine of C, right? So sine of C is the same process. I'm just picking a different point of reference, right? So let's pick C for my point of reference. And sine says opposite over hypotenuse. And I forgot to put cosine here. Cosine is adjacent over hypotenuse. So sine of C, opposite, that's 15, over the hypotenuse, that's 17, right? And so the reason I did that is because I wanted you to see that if we pick a different point of reference, cosine and sine could have the same value. So they both are 15 over 17, okay? So now let's go to the next one. Okay, so reference angle. Reference angle. A reference angle is an angle that's between 0 and 90. Okay, so it's going to be, it's not going to be over 90 degrees. And there are rules that go with whatever quadrant I'm in. So if I look at my sheet, if I'm in the first quadrant, my reference angle is just going to be um, whatever the angle is, right? And then if I'm in the second quadrant, I'm going to take 180 and subtract the angle from it. See, I'm using this little circle, well, I mean this zero with a line through it as I'm going to use that as theta. That is a Greek letter. We're using it as a variable, right? To represent our just angles. So if you see theta, that means it's an angle variable. So anyway, so if I'm like for instance 120. So if I want to know what the reference angle for 120 was, it'd be 180 minus 120, so it'd be 60, right? Okay, so what if I'm in the third quadrant? Well, the third quadrant puts me at say 210, 225, or 240, and if I'm there, right, I would say take that angle and subtract 180. So I subtract 180 from it. And so in this case, like if I was looking at 240, I would say 240 minus 180. 240 minus 180 is 60. So again, I'm back to 60. And then finally, if I'm in the fourth quadrant, so if I was looking at angles like 300, 315, or 330, let's say 300. So the rule says I take 360 and I subtract theta. So 360 minus 300 is 60. So then that would be my reference angle. Now, what's important to know is that your reference angle isn't supposed to come back and put you in your in the first quadrant. I mean, the quadrant that we're looking for is dependent on these angles here. That comes back when we deal with the next step. So I'll explain that in a second. So anyway, so 210, what quadrant is it in? First, second. It's in the third quadrant. The third quadrant says theta minus 180. So that's 210 minus 180. So the reference angle is 30 degrees. This little piece right here be 30. Now, next is, what is the value of sine of 210? So now I go back to my chart and see right here. If I focus on this right here, we're looking at 210, right? Well, 210 also has this. Come on, okay here. That right there, fine. This right here. So those coordinates are associated with it. The first coordinate is the cosine of 210. The second coordinate is the sine of 210. So if I'm looking at what is the sine value of 210, that just means I need to go to the second one. Notice on my chart, I wrote cosine and sine in parentheses in that order so I would know that all of these values are set up like that. So I don't get confused and think that the first one is sine. So the sine for 210 is negative 1/2. 1/2, and I'm done. So now we kick it up a notch and say, what is the reference angle for 570? Well, 570, that's more than 360. What we've been doing so far is we've been sticking to things that are between 0 and 360. It's like one circle, one revolution on our unit circle or our coordinate plane. Well, what if we get an angle that's more than 360? Well, so let's say 570. So I got two kind of trains of thought that I could go from. I could say I could divide 360 into 570 and see what my remainder is, or I could just subtract 360 and keep subtracting 360 until I get a number that is lower than 360. So if I subtract 360 from there, I get 210. 210 is lower than 360. 210 puts me back on my chart. See, 570 was not on my chart, but 210 is. So 210 was actually the problem that we worked with before. So that puts me right back here. And I want to know the reference angle for 210. So how do we figure that out? That's in the third quadrant. So that's going to say 210 minus 180, that's 30 degrees. Now, the second question says, what quadrant is the terminal side of 570? Well, think about it. Well, we just did it. So if I start here and I go around one circle, right, that's 360. And then I go 210 more, which is where I did, it ends in the third quadrant. So the only thing that we're concerned about is the amount that's less than 360. That kind of gives us a guide on what we're doing. If it's more than 360, I just want that remainder, just that little bit, that little piece, because that little piece is going to tell me, what my reference angle is and whatnot. So now I go, well, what is the value of cosine of 570? Well, we do the same thing. 570 takes us to 210 right here, and it's cosine and then sine. So the cosine of 210 is negative square root of 3 over 2. Okay, because I've got the 360, I don't really determine anything as far as, with that. What I do is I look at the last piece, and that goes to 70, or sorry, to 10. And that's where I determine my reference angle. That's where I determine what quadrant I'm in. That's also how I determine what my sine and cosine is. So I saw some folks, they got a little confused because I asked what quadrant they were in. And so they got to 210, right? And then they saw, oh, well, 210 is 210 minus 180. The reference angle is 30, so it's in the first quadrant. No, I'm not asking about what the reference angle is, because in every quadrant, the reference angle is less than 90. Okay, what I'm concerned about was that value that is less than 360. So in this case, it was 210. All right. And then finally, what is the value of tangent of 120? Well, I got this hint here that you should definitely make sure is on your chart. Tangent of theta equals sine of theta over cosine of theta. So why is that significant? Well, let's look at what we got. We said we were doing tangent of 120. So if you look at your chart, there is no tangent of 120, right? There's no tangent. There's cosine and sine according to this. So I go to 120. I'm going to write that over here. 120 is negative 1/2. Okay. So if I go to 120, I've got negative 1/2 and the square root of 3 over 2. That is the cosine and sine, right? Just make sure I got the right values. Negative 1/2, yep. Okay, so that's that. Well, what did I just tell you? I want the tangent of 120. Well, a tangent is sine divided by cosine. So that means it is the square root of 3 over 2 divided by negative 1/2. Now, why is that significant? Well, like I wrote in my notes here, tangent. To find the tangent, you use keep, change, flip. So what does that mean? Well, I've got fraction division, and fraction division is keep, change, flip. So the square root of 3 over 2 divided by negative 1/2. That ends up being the square root of 3 over 2 times, because that's the keep, that's the change. I change division to multiplication, and then the flip. So that's negative 2 over 1 now. So let's rewrite that. Let's rewrite that right here, and then we'll solve it. Well, if you look, this value and this value, they're the same. They can cancel each other out. Now, not the negative. It's important that you leave the negative because that's not involved with what we're doing yet. So I'm going to take away the 2, take away this 2. What you're really doing is it's a division problem. So it's saying 2 divided by 2. 2 divided by 2 is 1. So both of those values become 1, and 1 with this doesn't make any difference. I've got the square root of 3 times a negative 1, and then on the denominator, 1 times 1. So that is negative square root of 3 over 1, which makes my value of tangent of 120 equal to negative square root of 3. Because when 1's on the bottom, it just falls off. And let's give you a little darker color here so you can see, and then we'll call it. Okay, so that's a little too much. So tangent of 120 is the sine of 120 divided by the cosine of 120, which is negative square root of 3. And that's our quick review. Good luck. Just watch that problem, and we're gonna. I would also like to show you again my sheet. So if theta is over 360, keep subtracting 360 from the angle until it's smaller than 360. Okay, and that's for reference angle. And also you might want to say the reference angle is between 0 and 90. All right, and we're going to call it with that.